Let's go ahead and do the limit of g of x as x approaches negative 1, where g of x is the fraction x squared plus 1 divided by x plus 1. And like the previous example, if we put negative 1 right in here in place of x, we get negative 1 plus 1, which means we're dividing by 0. We're not just going to be able to plug the number in to figure out the value of the function. We're going to have to create a table. So again, we're looking near negative 1, where this was undefined. So I need to be slightly to the left of negative 1. So I'm going to go from negative 1.1 to negative 1.01 to negative 1.001. And on the right-hand side, I'm going to go from negative 0.9 to negative 0.99 to negative 0.999. I'm going to put those values into my function and see what I get out for g. On the far left-hand side, we get negative 22.1. The far right side, we get 18.1. So this is a little problematic. Remember, before, these numbers started out pretty close to each other. This time, one's positive and one's negative. They're nowhere near each other. If I move in a little bit closer, I get about negative 202 on the left and 198 on the right. They're getting even farther apart. If I move in even closer, on the left-hand side, I get negative 2002, and on the right-hand side, I get 1998. Not only are these two values not getting closer to some number because one's positive and one's negative, they're getting bigger and bigger. Remember, all the other examples got closer and closer to some number. Clearly, these one-side limits do not approach a number. The way we indicate that is we write either positive infinity or negative infinity, depending on whether the value is growing very, very negative. In that case, I'd go ahead and use negative infinity. Or is the number getting very, very positive, in which case I'd write positive infinity. Neither one of these means that we're approaching a number like we did before. It just means our outputs are getting really, really large as we get closer to negative 1 from the left or the right-hand side. Don't let this confuse you. First and foremost, the limit does not exist. And this just tells us why it doesn't exist. Either the values are getting really, really negative or really, really positive. What we would write here for the two-sided limit is as x approaches negative 1, g of x does not exist. It doesn't get closer to some value. If we look at the graph of this, what you'll notice is there's an asymptote at negative 1. And as we got closer and closer from the right, the y values were getting really, really big. They were shooting upwards. So that's why we wrote down there positive infinity. As we got closer and closer from the left, the graph shoots downwards. That's why our values were getting really, really negative. And so they're not zeroing in on some number. So the one-sided limits do not exist, and they approach either positive or negative infinity, and the two-sided limit. Since those two one-sided limits do not match some number, then the two-sided limits does not exist. So let's take another example. Let's do the limit as x approaches 2 of h of x, where h of x is this curious fraction here. It's the absolute value of the quantity x minus 2 divided by x minus 2. And you'll notice again, if we try and put 2 into here, the denominator is 0, so we just can't plug the number in. So I'm going to again make up a table with values that get closer and closer to 2, either from the left-hand side or from the right-hand side. If I put in 1.99 or 1.9 rather into this function, I get out negative 1. And if I put in 2.1, I get out positive 1. So these numbers don't seem to be very close to each other on the surface. One's positive and one's negative. If I put in 1.99, I get negative 1 again. If I put in 2.01, I get positive 1. If I put in 1.999, I get negative 1. If I put in 2.001, I get positive 1. Right away, I notice that I'm getting the exact same values on the left-hand side, always negative 1. On the right-hand side, I'm always getting positive 1. So right away, my one-sided limits make sense. As I approach 2 from the left-hand side, I'm getting negative 1. As I approach 2 from the right-hand side, I'm getting positive 1. But do those one-sided limits match? Nope. So what that means is since from one side I'm getting negative 1, from one side I'm getting positive 1, the two-sided limit does not exist.